Alrighty, so let's take a look at our warm-up here. It says to draw a scatter plot that could be represented by the following correlation. R equals 0.70. Okay, 0.70. Nehemiah. Put your phone away, baby. Thank you. All right, so first of all, is it positive or negative correlation? It's positive, which means my dots definitely need to show that they're increasing, all right? And then 0.70, how would we kind of describe that correlation? Weak, strong, moderate? Thanks. Okay. We probably call it kind of somewhere between moderate and strong, right, at 0.7. So we might do so we know it's going to kind of look like a line, but it may not be super close to it. So something like that, okay? So when we have that moderate relationship, okay, it looks like a line. It's not perfect, okay? You can make a few points closer to the main line if you wanted to, all right? But something like that should be about a 0.7. Okay, or 0.70. So what we're going to look at today is actually calculating the value of the correlation. Yesterday they gave me that number every time. So the good news is we're still going to use the same words to describe it, but we got to find the R number, all right? And lucky for us, it's going to happen in that applet that we've been using, okay? So we're going to calculate the correlation. We're going to talk about the properties of correlation. What all does it really tell me? And then what happens to the correlation if I throw an outlier in? Okay, so that's just kind of what we're looking at today. So we're going to go back and talk about Barbie, all right? So how can we be sure that the bungee cord we make for Barbie will keep her safe? Should we be worried if we choose the wrong axes, meaning I put the wrong variable in the wrong axes, or I use the wrong units, or if I enter data incorrectly? What could happen to Barbie, right? We don't want brains on the ground. So, we want to try to keep Barbie safe if at all possible. So here's her data, okay? So it gives us a bunch of data here. So let's go in and let's use our applet, okay? And we're going to look at the scatter plot, and I'm going to show you how to find the correlation, okay? I'm going to show you how to find the correlation. So let's go to our applet, and we're going to do the two quantitative variables. It's about, I think, the fifth or sixth one down, I think, when we get in there. So let's jump over there and look real fast. Okay, so go back up to the top. Yeah, 1, 2, 3, 4, 5. Yeah, it's the sixth one, two quantitative variables. Okay. And in that first column, we're going to put her rubber bands. So I'm just going to do number of bands. And in our response, we're going to put our distance. So just copying it straight out of there. And then we're just going to put our numbers in. Put everything in the top line. So 0 to 7. So 0 space. 1, 2, 3, 4, 5, 6, 7. And then we'll put those distances in that bottom line. So 12, 14, 17, 18, 22, 23, 26, and 30. Okay, so just putting our data in. So that's no different from what we did a couple of days ago. All right, so when we put that data in to create the scatter plot. And when we say begin analysis, it's going to show me the scatter plot. Now, if you notice, that's all it really shows me. But if we scroll down, what's the next thing that comes up? Calculate correlation. If you hit that button, it'll tell you R. Okay, so we're going to hit the calculate correlation button, and there's my R. Okay, which is nice. All right, so all I have to do is put the data in and hit calculate correlation, and it'll tell me. All right, so we don't have to do anything extra. All right, it's just one button we're going to push. So my correlation is 0.992. So how would you describe that?
Very strong.
Strong, very strong, and is it positive or negative?
Positive.
It's positive, right? So if we go back over here, all right, We've got R equals 0.992. We would say that is a strong positive relationship. Okay, a strong positive linear relationship. All right. Now, one of the things I want you to notice, did they put any kind of units of measure next to that correlation over on the applet? I don't believe so, right? All it says is R equals, right, down there at the bottom. And that's important because correlation has no units. All right, so if you're looking at a problem and it says the correlation is 0.992 feet, that's incorrect. It's just 0.992. Okay, so it's never got a unit of measure on it. So if you ever get one and they're like, is this true or false? If there's units next to it, it's false. Okay, because it does not have units. Now, so let's say we were working with our group and they made the mistake and they switched the variables. So they put distance on the top and rubber bands on the bottom. Do we think that may change what my scatter plot looks like? I don't know. Let's go in and look. That's why we've got the applet. Okay, so let's go in and let's put distance on the top and number of rubber bands on the bottom. I'm going to try to copy paste. Let's see how I do. Okay, so let me switch back over to my applet. And I'm going to go back up here and just put edit inputs, and then that way you should be able to switch everything around. So I'm going to put distance on the top. And then on the bottom, I'm going to put that number of bands. Okay. And now let me see if I can highlight that. Oh, yeah. And I'm going to cut it. And I'm going to go up here. And I'm going to space and I'm going to paste it. Yes. All right. And then I'm going to highlight there up to 7. And I'm going to, just kidding. Got fat fingers, y'all. Okay. And I'm going to cut that. I'm coming down the bottom row and I'm going to paste it. All right. And then I'm going to begin analysis. That scatter plot looks kind of the same, right? It's still positive. It's still increasing. Let's calculate the correlation. Does it change? Oh, look at there. All right, what's my correlation? It stayed the same. And that's one of the cool things about correlation. Even if I put the variables in backwards, it'll still give me the right correlation. Okay, so that's good news. We get in a hurry, we put the wrong line in first. Second line, we just mix up which one goes in which part. The correlation's going to stay the same. That's one of those properties of correlation. So we say there's no change. Okay, it is still 0.992. Okay, so that new property, it doesn't matter which variable we put in first. Okay, it just doesn't matter. All right, which is nice. Okay, so that gives us a little room for error and we can still get the right answer. So I like that. That's my favorite thing. All right, when I can mess up and still get the right answer. Okay, so correlation is going to have no units and it's not going to matter which one I put in first in the variable lines, right? It's still going to give me the right measurement. Right, for correlation. Now, this is interesting. It says, unfortunately, the group had measured the distance traveled in inches instead of centimeters. So to fix it, they converted all of their inch measurements to centimeters. And so they've changed that distance measurement, okay, to centimeters. Do you think changing the units will change the correlation? Okay, do you think it's still going to show me a strong positive relationship? Or is it going to change just because I use different units of measure on the bottom? What do you think? I think it's going to stay the same too, right? Because 30.48 centimeters is the same thing as 12 inches, right? So they already did the conversion, and that's true, okay? We're going to skip typing that in just because it takes forever, okay? So I would say that R is going to stay the same, okay? So that's what's interesting. That's another property of correlation. Changing the units on a variable does not change correlation. Okay, so it's not going to change my R number. So even if I get in a hurry and I'm like, oh man, I got the wrong units, and I changed the units and I put it in correctly, it's still going to show me that same relationship, which is nice. Okay. All right, and so then let's look at this one. It says one of the group members snuck some extra rubber bands in to collect some more data. Okay, so we're going to add a data point in. We're going to add in the data point 15, 124.5. So I am going to go in and put these numbers in this time. Okay, so I'm going to leave that top row. All right, so 1 through 7, then a 15. And then I'm going to put these centimeter measurements in. Okay, and we want to know, how is this extra point going to change my correlation? All right, because it will change it. The more data I put in, the correlation will change some. All right, and so let's go in and look. Let me switch over. And let's put some new data points in. Let's go up here and edit my inputs. So I'm back to the number of my rubber bands being on top. And I'm going to delete out that other stuff. And then I'm going to copy paste those. And I'm going to add a 15. Okay. And then underneath it, I'm going to put all those big long decimal numbers. So 30.48, 35.56, 43.18, 45.72, 55.88, 58.42, 66.04, 76.20, and then that new one, 124.5. Okay, we're going to begin our analysis. Right. So, can you see that we kind of got an outlier maybe out there somewhere, right? Because we've got this extra dot way out there. But does it look like it falls in the same line?
Yes.
Yeah, it kind of does, right? So let's look at our correlation and see what changed. So let's do calculate correlation. Oh, what happened? It changed a little. Did it get better or worse? They got better, right? It got better. We put another point in there that still followed the same trend, and my correlation got stronger. What do you think happens if I put a point in that's far away from the trend? Yeah, my correlation is going to get weaker. All right, it's going to get weaker. It's going to change. And so putting in an extra point is going to change that correlation. So on this one, R increased. Yeah, it increased to 0.998. All right. So because it was in the trend, our correlation gets stronger. Okay, so because it's in that trend, our correlation is going to get stronger. It's going to get a better number. It's going to get closer to 1 or closer to -1. Okay. All right, I'm going to go in. I'm going to make this one change on this last one. Okay, but I think you guys know what's going to happen. So they accidentally left off a digit. Instead of 66.04, they're going to put in 6 and then 6.04, and let's see what happens to the correlation. Okay, so I'm just going to go in. Bye, baby. Good luck. And I'm just going to change that 1 point and see what happens. Okay, to my correlation. So we want to verify. We said we're pretty sure that R is going to decrease. All right, because that's going to really change my data point, all right, the 6.04 from 66 is going to be a big difference. Okay, so let's see if we're correct. Right. So I'm going to switch over here, and I'm just going to do edit inputs, and that one that says 66.04, I'm going to take one of those sixes out. And then begin analysis. All right. And oh, look at my correlation. What did it change to? It's hard to see. Yeah, it really weakened, right? It definitely decreased. It decreased to 0.789, right? And the reason it did that is because that point is not in our trend, okay? So not in the trend. Another way you might say that is it's an outlier. The correlation will get weaker. Okay, so here's what we need to learn about correlation today. All right, one, how to put the data in and get the R number. Okay, lucky for us, the applet does that. Whoop, whoop. Okay, the next things that we needed to learn were all these things that I put asterisks by out through there. Okay, so if we go back and we look at everything, okay, correlation doesn't have units, it's just a number. Okay. Doesn't matter which variable we put in first, the correlation will stay the same. If I change the units on a variable, correlation stays the same. If I put in an extra point that's in my trend line, all right, or in my data, then it's going to get stronger. But if I put in an outlier, all right, or a point far away from the trend, the correlation is going to get weaker. That's all we got to be able to discuss today. All right, is what happens when I do extra stuff. All right. So let's organize these notes really fast. Yay! And so then we'll look at a couple of examples, and then when we get back from lunch, we'll be ready to rock and roll. Okay, and this is our last lesson. We're going to quiz tomorrow, okay? So let's take a look. Okay, so learning target 1 was just how do we get the R? Okay, so to calculate R, we're going to use our applet, 2 quantitative variables. And we want to be sure that we hit the button that says calculate correlation. Okay, so that's important. Right, so that was the first one we got to be able to do. Go to the applet. We're going to choose 2 quantitative, put our data in, calculate correlation. All right, it'll give it to me every time, which is good for us. All right. Learning target 2 was all about our properties for correlation. All right. Important things to remember. Correlation has no units. All right. Changing the units on a variable, R stays the same. Okay. And then if we switch our variables as we're putting them in, okay, so our explanatory and our response, if we switch the variables, R stays the same. So those are the properties of correlation. It has no units. Changing units on one of the variables, the correlation stays the same. If I switch the variables, correlation stays the same. Okay. The only thing that could possibly change that will change my correlation are outliers. Okay? So, things to remember. All right? If those outliers are in the pattern, okay, R gets stronger. And if it's outside the pattern, so it's way away from all of our other dots, R gets weaker. Okay. So that's what we need to know today. All right. And be able to do. Now, I'm going to actually skip the examples that are on this page just because I can't pronounce that word. I have no idea what it is. This one. It's asking if it's a flying dinosaur or an early bird. Archaeopteryx? But I don't know. Okay? I don't know. As we say at church, if you can't pronounce the name, just read it real fast and keep going. All right? Then maybe nobody will notice. You said it wrong, right? I don't know. Okay? So let's switch to those other three examples that I have for y'all, and let's just talk through them real fast. Okay, and let's talk through them real fast. We're going to skip that one, and let's look at these. Okay, just because they're smaller data sets and less information. Okay. All right, so the table shows the number of touchdowns and the number of wins for 4 teams in the NFC West division of the NFL during a recent season. It's not this season. And it asked me to calculate the correlation. Okay, it asked me to calculate the correlation. We have touchdowns and wins. Which one do you think is the explanatory variable? Touchdowns? Do touchdowns explain wins or wins explain touchdowns?
Touchdowns explain wins.
I would say touchdowns explain wins, but here's the great thing about correlation. Does it matter? No. Okay, we could put either one we wanted in first and it would be okay. All right, so let's jump over to our applet real fast. Okay.
Yeah, that's really old, 'cause it's the St. Louis Rams.
Yeah, it's really old, right?
Yeah.
Because where are the Rams at now?
LA.
LA, good job. All right. Okay, so we got touchdowns. Okay, I understand. And we got wins. All right. And we plug in those numbers. Come on, buddy.
9 years since the last time they were.
Hey, I don't collect this data. I just use it.
All
right.
I'm just saying, like,
It's really old, isn't it? 58, 49, 31, and 24. Okay? All right, and then we got 13, 10, 7, and 5. Begin analysis, calculate correlation, and there it is. All right, 0.991, which is nice. Okay, so those problems should be pretty simple when you have to do those. The hardest part will be just putting the numbers in. Okay, taking the time and making sure you don't mistype them. Right, so pretty straightforward. R is for freaking Hugan. 0.991. Okay. Now, let's look at these other two because this is where it talks about what would happen. Okay, what would happen? So look at this one. So the scatter plot shows the relationship between a 40-yard dash time and long jump distances. It tells me that the correlation is negative 0.838. Okay, makes sense. It's a negative trend right there. Okay, what would happen to the correlation if the long jump distance was plotted on the horizontal axis and dash was plotted on the vertical? What would happen if I switch the two variables? Nope. Nope. Properties say if I switch the variables, does correlation change? No. Okay, R would remain negative 0.838. Nothing's going to change. Okay, nothing changes, which is nice. Okay, if I switch the axis. On B, what would happen to the correlation if it was measured in feet instead of inches? Nothing. Okay, doesn't matter if I change the units, the correlation stays the same. Okay, yay. All right. Sabrina claims that the correlation between the long jump. Oh, all right, get you some lunch. We'll come back and finish these last two examples.